In this presentation, we're going to look at confidence intervals for means. So the general structure of a confidence interval is given as follows for when we're discussing the mean. First off, we have the sample mean, a value called the quantile, which I'll discuss later on, and lastly this thing called a standard error, which we have to compute. We also have this, we actually have two calculations. There is this symbol, the plus minus symbol, so it means we have to actually do two calculations, first a addition and then separately a subtraction, or vice versa. So what we have to do first is, let's look at firstly the quantile. Now these values are determined using statistical tables in many courses, but in other courses it just requires just learning off a couple of numbers. So for large samples, where samples are greater than 30 and where a normal distribution can be assumed, the quantiles are as follows. So if we're looking for a 95% confidence interval, which is by far the most common case, the quantile is the 1.96. Okay. So we're going to use this one here. So if we're dealing with 95% confidence intervals, the relevant quantile in that case is 1.96. Sometimes you might be asked to find a 99% confidence interval. Sometimes you will be asked to find a 90% confidence interval. Those cases are very rare. Usually it is 95%. The sample mean, which is denoted x bar, okay, that's how we verbalize that, is usually given in the question. Just a quick remark, in a lot of books it would be listed as the point estimate. The point estimate is a general term for all types of estimates that include the sample mean, values that are single values that are derived from a sample. So the standard error, now in this particular instance the standard error for the mean is computed using this formula here. So first off we have the sample standard deviation, and that's denoted S, and also we have the sample size n. So how do we compute the standard error? Well, it's actually simply the sample standard deviation divided by the square root of the sample size. So it's a relatively straightforward calculation. So let's look at an example. The length of life of a battery is estimated from a sample of 100 test items taken from a large population. So first off we have a large sample here and n is 100. So the mean is 57.4. X bar equals 57.4 and sample standard deviation is 15.1. Now compute a 99% confidence interval, or sorry, 95% confidence interval. That means we're going to use 1.96 as our quantile. So construct a 95% confidence interval for the mean length of life of all these batteries. So first off what we have to do is compute the standard error. So we have S equals 15.1 and the sample size is 100. So it is 15.1 divided by the square root of 100, that is 10, and that is simply equal to 1.51. So sorry, it's a 5 there. Let's draw that again. So 1.51 is the standard error. So moving on, we have to put all these values together. So we have our mean, sample mean, we have our quantile 1.96, and we have our standard error. Just as a remark, this part here, the product of these two terms is known as the margin of error in some textbooks. It's quite handy to know that actually sometimes. So anyway, what we have to do is calculate this. So it works out as 57.4 plus or minus. We're multiplying these two numbers out. We're just going to sort of round it to two decimal places. It works out to be 2.96. The lower bound is 57.4 minus 2.96. So the lower bound of the confidence interval is going to be 54.44. The upper bound of the confidence interval is 57.4 plus 2.96. And that works out to be 60.36. So that is our 95% confidence interval. (54.44 to 60.36). And that ends our presentation.